let's talk about something that is so fundamental to, well, everything we do, solving problems. I mean, from figuring out what's for dinner to tackling these massive global challenges, it's just a core part of being human. So, let's dive right in. You totally know this feeling, right? You're staring at an issue, you're turning it over and over in your mind, but the path forward, it's just not there. It's that universal experience of being completely and utterly stuck. But what if I told you there's actually a science to getting unstuck? Because really, at its core, this is all problem solving is. It's a journey. You've got a starting point, that's the problem, and you have a destination, that's the solution. The whole trick is just figuring out the right sequence of moves to get from point A to point B.
So, let's really dig in and try to understand what's actually happening inside our brains when we're faced with a challenge. How do we even begin to map out this journey in the first place?
Okay, I want you to think of any problem you're facing like it's a kind of mental maze. Before you can find your way out, your mind has to actually build the maze. So let's take a look at how it does that.
And this is such a crucial first step. You're not just blindly stumbling around in the dark, your brain is actively constructing a mental model, a map of the entire situation before it even thinks about looking for a path.
And, cognitive psychologists have a really cool name for this map. They call it the problem space. It's not just the start and end points. Nope, it includes every single possible state or situation you could find yourself in along the way. It is the full maze, complete with all its dead ends and winding corridors.
Now here's what's so fascinating, how that map gets built. It's really a combination of three key things. First, it's about how you represent the problem, how you frame it in your mind. Second, it's all your past experiences with similar situations. And third, it's your deep understanding of the problem's underlying rules and structure. These three things work together to draw the map that you're going to have to navigate.
Okay, so you've got your map, your problem space. But how do you actually move around in it? Well, that's where something called operators come in. Think of these as the specific actions, the tools, or the moves you can make to get from one point to another. Finding the solution is really just about finding the right sequence of these operators.
All right, so we've got a map, and we know we need to take steps to get through it. But which steps, and in what order? Let's start building a toolkit of really powerful strategies for navigating that mental maze a lot more effectively.
Okay, this one is a real game changer. Means-ends analysis. I know, it sounds a little complex, but it's incredibly logical. You just start by looking at the biggest single difference between where you are and where you want to be. Then you create a little mini-goal, a sub-goal, just to reduce that one difference. You find an action to achieve that, and then you just do it all over again. You keep knocking down the biggest obstacle, one by one, until you get to the end.
And this shows you exactly why that strategy is so powerful. There's a simpler one, called hill climbing, where you just take whatever next step seems to get you a little bit closer to the goal, but that can be really short-sighted, right? It can lead you right into a dead end. Means-ends analysis is much more strategic. It's willing to take a step that might feel like it's moving you further away from the goal if that step is what's needed to overcome a huge obstacle down the line. It's playing chess, not checkers.
And hey, means-ends isn't the only tool in the box. You can use analogy. That's where you borrow a solution from a totally different problem that just happens to have a similar structure. Or you could try working backward, which is fantastic when the goal is way clearer than the starting point. And of course, there's the classic. Just break one giant problem into smaller, much more manageable subproblems.
Have you ever been stuck on something for hours, maybe even days, and then, all of a sudden, in a flash, you just see it, that aha moment? Well, that's not magic. It's a real cognitive process called restructuring. It's when your brain literally changes how it's representing the problem, shifting its perspective so that the path to the solution becomes instantly, blindingly obvious.
Of course, even with the absolute best strategies, we all get lost sometimes. So why is that? Well, it turns out our brains have a few built-in roadblocks that can trap us inside that maze. Let's take a look at a couple of the most common ones.
So picture this. You need to hammer a nail into the wall, but the only thing you've got lying around is a heavy metal wrench. Now, for a lot of us, the solution doesn't immediately jump out. Our brain kind of gets stuck on what a wrench is for, and that creates a mental block. And that roadblock is called functional fixedness. It's our brain's tendency to get locked into the typical everyday function of an object. We see a wrench, we think turning bolts, not heavy thing for hitting stuff. The key to breaking this is to stop asking, what is this object's purpose? And instead start asking, what are this object's properties? A wrench is hard, it's heavy, it's metal. Those properties make it a perfectly good hammer in a pinch.
Oh man, here's another one I think we've all been guilty of. You try a certain approach to solve something, and it doesn't work. So what do? You try it again, maybe just a little bit harder this time. And then again. You get stuck in this loop, and you just can't see that the approach itself is the real problem.
This is called a negative set. It's basically a mental rut. Our brains are biased to stick with a strategy that's worked for us in the past, even when the current situation desperately needs a new way of thinking. A great way to escape this is to force a new path on yourself. Just tell yourself, okay, I have to solve this, but I'm not allowed to use my usual method. It's often the fastest way out of the rut.
So, how do we get better at all of this? How do we overcome these roadblocks and become masters at navigating the maze? Well, we can learn a lot from the masters themselves, the experts. What is it that makes an expert so much better at solving problems in their field?
And this table just lays out the difference so clearly. A novice, like most of us, sees the surface features of a problem. But an expert, they see the deep, underlying principles. A novice has to consciously think through every single step, while for an expert, so much of that process has become automatic and efficient. But the biggest difference of all, it's not just that experts know more things, it's that their knowledge is incredibly well organized and structured.
So here it is, the crucial point. Building expertise isn't about cramming your head with more and more facts. It's about building a rich, interconnected web of knowledge. It's that structure that lets experts instantly recognize patterns, pick the right strategy, and see the path through even the most complex mazes with absolute clarity.
So there you have it. You now know how to map your problem space, how to choose the right strategy to get through it, and how to spot those sneaky mental traps like functional fixedness. You literally have a new toolkit for thinking. So the only question left is, what problem are you going to look at differently now?